Hi there, welcome to this session. In this session, we are going to discuss about instruction format. In the few classes, I have already told you that what is instruction and what are instruction formats. And we just got the brief idea about the instructions in the previous classes. We also discussed about the different type of CPUs like accumulator based CPU, register based CPU, and stack based CPU, and we have already covered that the merits and demerits of different type of CPUs and what are the different uses of the CPUs and which CPU is a good one. We have already uh, discussed with by solving with that expression. So this session we we will get the brief idea about the instruction formats. So in this session these much topics to be covered. Okay, the different instruction formats according to the address. That is three address instruction format, two address instruction format, one address instruction format, and zero address instruction format. So let me describe few things about instruction format. An instruction is a command to the computer, as you know that, because in computer all hardware units implement the instructions and it is specified with their binary code formats. So the format of an instruction is usually pictured in a rectangular box which is shown here. Okay. And it is symbolizing the bits of the instruction as they appear in memory words or in control registers. So in this way, this according to this structure, we can assume that the instruction can be present inside in a memory words or it can be present in a control registers. So the instruction can be divided into different groups that is called fields. These are operation field, operation code field, an address field, a mode field. So basically the operation code field is a group of bits that defines various processor operations such as called add, subtract, multiplication, move, div, everything. It also supports the complement and shift, etc. The operand resides in memory are specified by their memory address. Okay. If the operand reside on processor registers are specified with the register address. So that means we can have two address field. One is the memory address field, another is processor address field. So okay, as I said, address can be divided into different categories. One is memory address and processor address. So if the operand is reside in the memory, then it will go for the memory address. Or if the operand is reside in the register register unit, then it can use the sorry, processor unit, then it can use the registers. Okay, so this is the small structure of an instruction that can be uh, assumed. Okay, this is the opcode. Basically the opcode is related to the operation code field. Okay, then address is related to the address field. So basically it's to memory and processor. The mode is basically defined to that which addressing mode it is going to use. Okay, so whether it is absolute or direct or different addressing modes. So in our coming classes we have addressing modes. There we will discuss the different type of addressing modes and their use. Okay, so this is all about the instruction, and again I would like to repeat here, the instruction is nothing but it is a command to the computer to perform any task. Okay, given task. So the instructions can have a different formats like three address instruction, two address instructions, and one address instruction, as well as zero address instruction. So let us see what is the meaning of three address instruction format. So if the instruction or in these three address instruction formats, each address field is specified to the processor registers or the memory address. Okay, if the operand is stored in the register, so it must use the processor register. If the operand is stored in the memory address, then it use the memory address. Okay, So suppose this is our expression that x equals to a plus b cross c plus d. So to solve this expression with three address instruction format, then we have to need three different type of address. Okay, three individual address. So if it is processor register, then it can use the registers. If it is memory address, then it can use any operand address. Okay, so we can also use the mixture of both processor registers and memory address register to perform this task. So this is the first instruction to evaluate this expression. The instruction is add is opcode this r1 ab. So r1 ab are three different components or three different operands. So here a and b holds the data which is already given through this expression, and whatever the information is there, that will move to the r1. And the movement of data is there. Okay, so it means that both the memory unit of A will added with the memory unit of B, then it will move to R1. So R1 will hold the addition of A and B. Okay, so this is another instruction for this operation, that is C plus D. And through this instruction, it defines that the content of C will added with the content of D, and after that addition, the result will move to R2. Okay, so now the next operation is we evaluate the A plus B and we evaluate the C plus D, and after that we have to evaluate the multiplication. To do the multiplication, we need mul is the uh, opcode, and this instruction defines that whatever um, opcode value is there, that will multiply with each other. Okay, so that means r1 is multiplied with r2 and the result will move to x. So this way the expression can be solved with the three address instruction format. In three address instruction format, we need three different operand values or operand address, so that our expression can be solved. Okay, so what is the benefit of using three address instruction format is that we can uh, minimize the length of the program. Okay, if we have a number of addressing, or we have a number of storage elements are there, then we can minimize the length of the program. Okay, we have a um, different registers, we have a lot of registers, so that we can have option to solve the complex information or complex instruction. Okay, so next type of address format is two type of address format or two address instruction format. In if we compare these three address instruction format and two address instruction formats, so in basically in two address instruction format, maximum two number of operand address can be used. Okay, in the instruction. So let's see what is that. In two address instruction format, same each address field is specified by the processor register or the memory address, or it can be used both. Okay, say for example, this is our expression x equals to a plus b cross c plus d. To solve this expression, we have to write the instruction. Here the instruction specify that move r1a, that means the content of a is moved to r1. Okay, so this move instruction specify the this is the operation code. This operation code specify that the content of a is moved to r1, where r1 is the processor register and a is the opcode address. Okay, so next after moving of a to r1, then we have another operand value, that is b. Then with this instruction we add the content of r1 and the content of b, and after that the result will move to r1. Okay, so now this a plus b is over by just writing the two statements with two address instruction format, and after that we have to do the operation of c plus d. For that we need a instruction move r2 c, where r2 is a register, processor register, and c is a opcode address. Okay, that means the content of c is moved to it will move to the register r2. Then this instruction add R to D. It means that the content, again the content of both R2 and D will added together and the result will move to R2. Okay, so now we have already done A plus B and C plus D. Okay, then the next operation should be the multiplication. For that we need a opcode, that is MUL, and we have already the result in R1, that is the A plus B, and we have already result in R2, that is C plus D. So to perform that we need an instruction, that is MUL R1 and R2. So that means the both R1, the content of R1 which is the result of A plus B, and the content of R2 which is the result of C plus D, both will multiply with each other and it will store in R1. Okay, so after that we have to vacant the R1 to further processing activities, so that we use a move. Okay, or you can use store. Okay, here I am using move. This instruction specify that the content of R1, so here now the R1 holds A plus B cross C plus D. Okay, the content of R1 will move to X. Clear? So now when this instruction is executed, the R1 will vacant one, and it is ready to receive a new data. Okay, so this way the two address instruction formats works. In two address instruction formats we need at least two memory address, maybe the processor register or maybe the memory address register, or sorry, memory address. Okay, if you compare these two address instruction format and three address instruction format, then the three instruction format program size is compact, or it is short program as compared to the two address instruction format. So there is another instruction format, that is one address instruction format. So here in one address instruction format, basically it uses the accumulator registers to perform all kind of data manipulation activities. So data manipulation activities like moving of data and adding of data, or do any binary arithmetic operations of the data, everything is called data manipulation, or shifting of data or storing of data. So every data manipulation activity can be done with the accumulator registers. That means there is no question about processor register memory address in case of one address instruction format. So in one address instruction format, the program size is big one as compared to two address or three address instruction formats respectively. So let's see, we have an expression again, that is x equals to A plus B cross C plus D. To solve that expression with one address instruction format, then we have to follow this instruction, that is load A. That means when we write this instruction, or when we give this instruction to the CPU of a computer, then the computer fetch the data from A. Okay, fetch the data from opcode address A, and it load to accumulator. Okay, now the accumulator contain the data. So the next instruction, that is add B. So that means we have already data A in accumulator. Then when this instruction will execute, that is add B, so the content of B is added with the content of accumulator, and it will again store back in accumulator. Okay, so now the accumulator contains A plus B. After executing these two statements or two instruction, the accumulator holds the result of A plus B. The next is that we have to vacant the accumulator to receive other data, so that we use a temporary memory location, that is T. So when this instruction executes store T, so it means that okay, store T. So it means that we need to vacant the accumulator, because accumulator is going to receive a new data in the form of C and D. So we have to use the temporary memory location. Okay, so after that we again load C to perform C plus D operation. The same way these two statements or two instruction works, that is load C, it will load the content of C into accumulator, then load D. So that means the content of accumulator plus the content of D will add it together and it will store the content of accumulator. Okay. So after that, after the performance of A plus B and C plus D, see the result of A plus B is stored in T, that is a temporary memory location, where the result of C plus D is available in accumulator. So next instruction is to multiply that, the two terms, two result. So mult mul then T, that means this instruction specify that, or instruction describe that the content of accumulator is multiplied with the temporary location T and the result will store in uh, accumulator. Okay, then we have to write another other instructions to vacant the accumulator, because the accumulator should be vacant one, to do the further data manipulation applications or data manipulation activities. So that we have to use the store x command or instruction to retrieve the data from the accumulator and store in x. So this way the one address instruction formats use. So if we compare the one address instruction format with two address, three address instruction format, then the program size is it varies the program sizes. Okay, in some, in three address instruction format the program size is very short, and two address instruction format the program size is a little bit short. Okay, if one bit one address instruction format the program size is lengthy. Okay, so just to remember that in one address instruction format only accumulator registers are used, whereas in two address instruction format and three address instruction formats we can use processor register, and the same time we can use a memory register, or we can use the memory register or processor register. Okay, so next instruction format and the last instruction format is the zero address instruction format. Basically the zero address instruction formats we work with the stack based CPU, and we know that stack is work with the two operation, that is the pop and push. Okay, pop operation is means that to retrieve the data from the stack element or stack structure, and pop push means to insert the data into the stack element. Okay, so and in previous classes we came to know that in stack based CPU doesn't use any address field, so that is called zero address instruction format. Okay, suppose we have an expression that is x equals to a plus b, that means we have a two operand in the form of a and b, and some data is inside a and some data is inside b. We have to perform the addition of the two data and it will store back in x. So to perform this expression with the zero address instruction format, then we need the following instructions, that is a push a. So in the last videos I said that how the stack is work. Okay, basically the stack is work with like this is the stack container, and the stack container is associated with the stack pointer. Okay, the stack pointer is a type of special type of register which is defined as stack register. Okay, stack pointer. Okay, so the stack pointer defines that whether the stack is empty or not. If the stack pointer is 0, then it is assumed that the stack is empty. If the stack pointer is 1, the stack has have one element. Similar way, if the stack pointer is increasing, then we assume that the number of elements inside the stack. Okay, so initial stage, the stack pointer is always 0. When we are doing any kind of operations, we assume that the stack pointer is the stack is 0. The stack pointer remains 0. Okay, at the 0 location. So when this statement is executed, then the stack container takes a value a. The same time stack pointer will incremented by 1. So we can write here the position of the stack pointer, that is 1 when execute this statement. Then the next statement is again push b. So it means that first we have to insert the this element, stack element, or sorry, this operand code or opcode into the stack, and we have to insert another operand into the stack, that is b. So now we we have b into the stack element by just writing this code. Okay, by just writing this statement or instruction, the b will be inserted into the stack. Okay, now the stack pointer will incremented by 2. So when I say the stack pointer is 2, it means that, or it defines that there is minimum two element inside the stack, or at most two element inside the stack. Okay, when I say stack pointer is 1, then it assumes that the stack structure holds a single element. Okay, so after we are getting the two operand values, that is a and b, then our next job is to add these two value. Okay, so to perform that we need an instruction add. So when when this instruction is executed, that is add is execute, then it will simply perform that addition of two code. Okay, that is a and b. So now the stack holds. Okay, now the stack hold a plus b. Again, the stack pointer is 0. Now the stack holds one value, that is a plus b. So when it performs the addition of these two opcode a plus b, then this stack pointer will reduce back to 1. Okay, so now stack pointer is 1. Okay, so when the stack pointer is 1, then it is assumed that the stack structure holds a single data elements. Okay, so after that we need to vacant the stack element so that we see the result. Okay, so for that we have to pop out that addition result. So to perform that we need this instruction, that is pop x. So that means the x will